In this video, we are going to study about multiple products of vectors. So first, let us discuss the product of two vectors so we can clear the basics. So first we have here is scalar product, which is also called the dot product of two vectors. If a vector and b vector are any two vector and theta is the angle between them, then the scalar product is denoted by a vector dot b vector, defined as magnitude of a vector, magnitude of b vector, and cos theta, where magnitude of a vector is a and magnitude of b vector is b. From above equation, it is observed that a vector dot b vector is scalar. Why? Because the magnitude of a vector is a and magnitude of b vector is b, and both are scalar quantities. And cos theta is also scalar, so we can conclude that the dot product of two vectors gives us scalar. Now, let us begin with vector product, or which is also called cross product of two vectors. The vector product of two vectors a vector and b vector is denoted by a vector cross b vector and is defined as magnitude of a vector, magnitude of b vector, and sine theta n cap. Here n cap is the unit vector perpendicular to both a vector and b vector. So here we have completed the basics of the product of two vectors. So now let us begin with the triple product. We know, as we discussed above, a vector cross b vector is a vector. So therefore we can find its dot product and cross product with another vector c, which gives us the triple product. Thus we can find a vector cross b vector dot c vector, which is scalar triple product, and a vector cross b vector cross c vector, which is vector triple product. Why we are calling it scalar triple product? Because we are here taking dot product of this vector a cross b and another vector c vector. And why we are saying vector triple product here? Because we are taking the cross product of vector a vector cross b vector and the other vector, which is c vector. Now let's begin scalar triple product, which is we already discussed, is denoted as a vector cross b vector dot c vector, which has a determinant form represented as this. So now we are going to derive this determinant form. Let a vector be a1 I cap plus a2 j cap plus a3 k cap, and similarly the other vector b vector and c vector also. Here I cap, j cap, k cap are unit vector mutually perpendicular. So now here a vector cross b vector is equal to the determinant I cap, j cap, k cap, a1, a2, a3, b1, b2, b3, because we are taking a cross product with b. So we take these first equations and then we put it in the determinant. Now we are going to solve this determinant. We got this value. First a2 b3 minus a3 b2, then multiply it with I cap, and then we have a3 b1 minus a1 b3, then multiply it with j cap, then plus a1 b2 minus a2 b1, then multiply it with k cap. So here we have the expression for a vector cross b vector, which is this, and we already have let the value of c, which is c1 I cap plus c2 j cap plus c3 k cap. So now we are calculating the dot product of c vector with a cross b vector. So here what we get is a2 b3 minus a3 b2 and multiply it with c1. Similarly the other part also. So we get this equation. So if we compare this equation with this equation, we can write this according to this determinant form. So we just replaced here I cap, j cap, k cap with c1, c2, c3 by comparing this equation. So now what we do is we are interchanging first and second row. So we get this. We take negative sign because by interchanging these rows we are changing it anti-clockwise, that why we get minus sign. Then we are changing the row 1 and row 3, so we get this determinant, which is equal to a vector, b vector, c vector. So we get the determinant form of the scalar triple product, which is equal to this.